In the heart of the universe lies one of its most captivating mysteries: black holes. These cosmic phenomena defy our understanding, warping space and time in ways that challenge our very grasp of physics. They are nature's ultimate enigmas, representing both the end of a star's life and the beginning of a new realm of scientific exploration. Today, we invite you to embark on a journey through the dark recesses of the cosmos, uncovering what black holes are, how they form, and what they reveal about the universe we inhabit. So, what exactly is a black hole? At its core, a black hole is a region in space where gravity is so intense that nothing, not even light, can escape its clutches. Picture a star, luminous and vibrant, reaching the end of its life cycle. It exhausts its nuclear fuel, and gravity begins to overpower the forces that once held it together. In this critical moment, the star undergoes a dramatic transformation, collapsing inward under its own weight. This cataclysmic event, often culminating in a supernova explosion, results in the formation of a dense core. If this core is more than about 3 times the mass of our Sun, it can collapse into a black hole. A singularity surrounded by an event horizon. Within this boundary, the gravitational pull is so strong that the laws of physics, as we currently understand them, cease to apply. This paradox invites us to ponder the very nature of existence. Black holes come in various types, each with its own fascinating characteristics and mysteries. The first type is the stellar black hole, typically formed from the remnants of individual massive stars. These stellar black holes can range from about 3 to several tens of solar masses, representing a significant gravitational force in their vicinity. Then we encounter supermassive black holes, the titans of the cosmos. Found at the centers of galaxies, including our own Milky Way, these colossal entities can possess masses equivalent to millions or even billions of suns. Their gravitational influence extends over vast distances, shaping the structure and dynamics of entire galaxies. At the heart of our galaxy lies Sagittarius A, a supermassive black hole weighing about 4 million times the mass of the Sun. Its powerful gravitational field governs the orbits of stars and gas clouds in the galactic center, providing a crucial window into understanding the evolution of galaxies over billions of years. But how do we detect something that, by definition, is invisible? Black holes themselves emit no light, making them elusive to direct observation. However, we can study their effects on nearby stars and gas. As matter spirals into a black hole, it forms an accretion disk, a swirling vortex of gas and dust heated to extreme temperatures, emitting X-rays and other forms of radiation. With powerful telescopes, we can detect these X-rays, revealing the presence of a black hole. In a groundbreaking moment for astrophysics, the LIGO Observatory made history in 2015 by detecting gravitational waves, ripples in space-time produced by the merging of black holes. This monumental discovery not only confirmed a key prediction of Einstein's theory of general relativity, but also opened a new era of astronomy, allowing us to listen to the universe's most violent events. At the core of a black hole lies the singularity, a point where gravity is thought to be infinitely strong. Here, matter is compressed to an unimaginable density, and the laws of physics as we know them break down. Surrounding this enigmatic core is the event horizon, the point of no return. Once an object crosses this boundary, it cannot escape the black hole's gravitational pull. For observers watching from a distance, it appears as though time slows for anything approaching the event horizon. In stark contrast, for someone crossing this threshold, they would experience a different reality altogether, one defined by the unforgiving nature of the black hole's gravitational forces. What lies beyond the event horizon? This question remains one of the greatest mysteries in modern astrophysics. The event horizon is a fascinating concept. It represents a boundary that defies our understanding of reality. What happens to information that crosses this boundary? Does it disappear forever, or is it preserved in some form? The singularity challenges our comprehension of space and time. It compels us to rethink fundamental principles in physics, possibly requiring a new framework that bridges general relativity and quantum mechanics. Black holes are not merely cosmic vacuum cleaners. They play a crucial role in the universe's structure and evolution. Their powerful gravitational fields can influence the orbits of nearby stars, and they can even drive the formation of new stars in their surroundings. As black holes consume matter, they can generate high-energy jets that shoot out into space, releasing radiation across the electromagnetic spectrum. These jets can reach speeds approaching that of light, impacting the interstellar medium and facilitating the birth of new stars in the process. In some instances, black holes can merge, releasing immense energy detectable across vast distances. These cataclysmic events provide valuable insights into the formation and evolution of galaxies, revealing a dynamic and interconnected universe that continues to evolve. The study of black holes is a rapidly advancing field, filled with untapped potential and exciting discoveries on the horizon. Upcoming missions, such as the James Webb Space Telescope and the Event Horizon Telescope, promise to deepen our understanding of these cosmic giants and the critical role they play in the universe. These powerful instruments will allow us to peer deeper into the cosmos, examining black holes in unprecedented detail and seeking to answer age-old questions about their formation, behavior, and ultimate fate. With each new discovery, we come one step closer to unlocking the secrets of the universe. As we gaze up at the night sky, we are reminded of the vastness of the universe and the incredible mysteries it holds. Black holes, with their powerful gravity and enigmatic nature, challenge us to think beyond what we know and inspire us to continue our quest for knowledge. They are not just cosmic phenomena. They symbolize humanity's endless curiosity and our desire to explore the unknown,